Hi guys, in this video we are going to discuss about the polar form and Cartesian form representation of voltage. If you are new to this expert tutor channel, please do subscribe. Also in the previous video we have discussed what's meant by the polar form as well as the Cartesian forms. Here we are going to discuss an interesting question from that part. As you can see over here, they have given the voltage, the total voltage with respect to the time is going to be 100 sine 1000 t minus 30 degrees, which simply means this is the general form of a voltage or current. So this is the general form. In this general form, we already knew that this 100 part is going to be the maximum value of the sinusoidal waveform of voltage, and this omega, after this sign we are going to get omega t plus phi. The omega is going to be 1000 radian per second, and this phase angle, initial phase angle, is going to be minus 30. So this is the general form. But the thing over here is we can represent this value in two different ways, which is one is polar form and the next one is Cartesian form. So we are going to discuss how to convert them. Before that, they have asked a simple question to find the maximum value. VM simply means the maximum value of voltage. You can totally tell it's going to be 100, and we need to find the VRMS value as well as average value of voltage and omega and phi. You can tell the omega value is going to be 1000 radian per second minus 1, so radian per second, and this phi is going to be minus 30. But we need to use some calculations to figure these two values. In the previous video also I have mentioned we can use the equation directly to find the RMS value of a current if we have given a sinusoidal waveform. Generally, when you are having the electrical engineering basic tests or any papers, you can see that normally we are going to get from the sinusoidal waveform. So from that I'm going to use the equations directly. The VRMS is equals to V maximum divided by root 2. So if I substitute that, I'm going to use the calculator over here. So the Vm value, I knew that it's going to be 100 divided by root 2. It's going to return the 70.71. So let's write that 70.71 voltage. Likewise, we can find the value for V average. It's going to be first of all you need to know the equation. It's going to be 2 by pi into VA, the maximum value into 2 by pi. So let's substitute over here. 2 divided by pi into the V maximum is going to be 100. It's going to return 63.661. So let's write 63.66 voltage. So now we have found the value of V RMS as well as V average. The next work we need to do is we need to find the polar form as well as Cartesian form. So actually we have discussed what we mean by the polar form is we are going to represent this voltage as it is. However, we are going to change the representation method. Let's say you have already learnt about the binary decimals, which simply means we are going to represent a number or digit. However, we are going to represent in many methods, but the thing is they are all going to give the same value. Let's say if you are considering about the number 2 digit, number 2 in the decimal you can directly write it as 2, but when you are considering about the binary code, it's going to be different. It's going to be 1 0, but the value of the two things, the two numerical value of these two are going to be same, which is 2. Likewise, we are going to return the same value. However, we are going to change the format. So if you are considering about the polar form, we are going, first of all we need to know the VRMS value. After that we need to find this phasor angle. So when you are considering about this, the VRMS would be, we have already found that it's going to be 70.71. the angle would be minus 30. Be careful, you need to use this minus 30 from the reference line. It's going to be in the negative direction, so you need to put minus 30 over here. So this is in the polar form. This like polar form. So from this polar form we can directly derive the Cartesian form. Let's say I'm going to draw this phase diagram over here. It's going to be minus 30, so you need to draw like this. It's going to be minus 30. So when you are considering about the ax and ay over here, the value of this ax and ay over here, let's say this is going to be the ax. In other term, you can tell it like vs and by. It's not a general term. You can use any terms. So when you are considering about this one, actually we knew this value is going to be the VRMS, which is 70.71. This is the phase diagram. This is in the polar form, 70.71 in the direction of minus 30 degrees. So from that we can directly tell AX is going to be 70.71. Then we are finding the magnitude. We are not considering about the minus 30. So 70.71 into sine 30. Likewise, we can directly find AY is going to be 70.71 into cos 30. So now we need to find the values. If I substitute half for the sine 30, we are going to get 70.71 divided by half is going to be 35.355. Let's write 355, so 36 voltage. When we are considering about the y direction, it's going to be 70.71 into root of 3 divided by 2. It's going to be 61.24. 61.24 voltage. So when we are considering about the Cartesian form, we need to use this general notation. It's going to be let's say this is AX plus JAY. So when we are considering this, we can directly 35.36. Be careful, we need to use the minus sign over here. The reason behind this is we are going to consider in the negative direction, so we need to use this minus. Otherwise you can tell, if you are considering about as this is the x-axis and this is the y-axis, you can tell from the y part is going to be in the negative direction, in the minus direction, so you need to always put this minus sign over here. So it's going to be minus j. The AY, J simply means it's in the y direction, and the AY is going to be 61.24, like voltage. So this is in the Cartesian form. In this question we have discussed about these two forms. Also we have already done a video regarding how to find this Cartesian form from a polar form directly in a calculator. If you don't know, please watch that. It would be useful in your exams too. So here I'm going to check this answer whether it's correct or not using a calculator. So let's do that. So if you haven't watched that video, I have given the link in the description. Please watch that, because in this video I'm going to do very fast. In that video I have already explained about that. So we are going to set up this one for a complex number. After that I'm going to change the output to Cartesian form. Cartesian form is a plus bi. After that I need to write this phase angle. It's going to be the phase form, the polar form. It's going to be 70.71 and the angle would be minus 30. If I write the equal sign, it's going to be it's going to return 61.236 minus 35.355. So I have made a mistake over here. Sorry, it's going to be cos 30. Yes, it's going to be cos 30, and this is going to be sine 30. That's why we have made a mistake. So it's going to be 61.24, and here it's going to be 35.36. Likewise, we need to change this. It's going to be the minus j 35.36, and this is going to be 61.24. So the thing over here is actually you can directly use this calculator and directly format this one, or else, as I have already mentioned, when you are considering about this one, the AX is going to be 70.71 into cos minus 30, and if you are considering the AY, you can directly substitute 70.71 into sine minus 30. If you do so, you are going to get the answer in the minus, so you don't need to change this sign over here again. If you use the substitution of minus 30 over here, it's going to be 70.71 into sine minus 30, which will return the AY as minus 35.36, so you don't need to change this plus sign over here. Otherwise, you can directly find for the positive angle. After that, you need to consider whether it's in the plus direction or minus direction and change it like this one. Sometimes, in some cases, it might be the real value, the AX value can be changed, can have the negative value too, if that in the direct negative direction of the x-axis is going to have that negative value, so it can be changed. So the thing over here is you can easily change this using a calculator. So if you haven't watched that video, please watch that. I have mentioned how to use how to solve the complex number problems, and how to change or how to convert from the polar form to Cartesian form, as well as Cartesian form the polar form, directly using Casio FX901EX. So in this video, I hope it would be very useful for you. If you have any doubts, please comment it below. Thank you.